All right, hi everyone. We're at one of the last sessions of the day, so I figure that people are a little tired. I'll probably need a little bit of your concentration. This is going to be an important topic. We're going to talk about data in machine learning. The title of our session is High Performance Feature Engineering for Predictive and Gen AI Workloads. And I'm going to be demoing Vertex AI Feature Store. My name is Alex Martin. I'm the product manager for Vertex AI Feature Store. And with me is Kaz Sato, all the way from Japan. He's our developer advocate and also a resident generative AI expert. Today, we'll talk about data in machine learning, the many problems that you may encounter as you try to use data in ML. Then I would introduce Feature Store as a solution to many of those problems. Kaz will do a cool demo of how you can actually use Feature Store. And we'll wrap up with some feedback from the customers who already tried Feature Store and also helped us develop it. So let's kick it off. Now, in our industry, models get the spotlight. If you look at all of the newspaper articles, all the blog posts, they talk about the ever-complexing architectures and all the different ways that we're making the tensors flow. However, if you ask actual AI practitioners who ship projects, almost all of them would tell you that the fastest, most sure way to improve your machine learning outcomes is to focus on your data. Easier said than done, because there's a lot of challenges in how to use data for ML. It's right there at the center of everything you do in MLOps. ML features are compiled into a training data set that actually is the foundation for your model to learn from and act as you want it to act. And then the same features need to be passed into the training endpoint, often at a very, very low latency and with exact same transformations, just so that you can avoid train serving skew. And I've heard some tell me that, oh, but this is a generative AI era, this is foundation models, all the data is encoded, they're kind of like APIs, it's no longer as important. Well, if you heard terms like RAG, grounding, fine-tuning, these are all techniques that are actually used to make LLM apps work in production. And all of those techniques are rooted in effective use of data. And if you're one of those few companies that actually trains the generative models, then nothing changed for you. You still have to compile these massive data sets to actually improve your models. Now, it's already pretty clear that very few companies are actually going to be training the models, training the large models. And most companies, in order for you to future-proof your business, whether you're an ML company or any company for that matter, the best way is to compile a really good predictive data set. So there are some challenges in actually having that data and using it for your ML models. Number one is being able to centralize all of the features that you're using across different projects and different organizations. I've seen many teams where you'd have exactly the same feature, something trivial, like average revenue per customer per day. The same feature being created in multiple projects, hell, even in the same project sometimes, where it's diligently there with an ETL pipeline, removing outliers, cleaning up various attributes. And all of this is done in exactly the same way for exactly the same feature twice or three times because the data scientists didn't know that this feature already existed and another team has created it, has shipped it, there is a model running it, but they had to create it from scratch. Next up is train serving skew. Probably the single most popular reason why models disappoint in production. Train serving skew is any time when whatever you've done in training cannot be replicated in serving. An edge case of train serve skew is data leakage. And this is probably the surest way to crush a data scientist spirit is to show them that the reason their model is finally behaving well is not their grit or their smarts, but because they leaked some data into the training variable. This happens all the time. Many of us have stories to show how you've done everything right, but then you forgot that this one variable was not correctly looked up in point in time, and the data leaked into your model, and then when you deployed it in production, it didn't work well. Serving environments are actually really constrained, so train serve skew is often inevitable. because whatever you've done at your training time, you've used some common libraries, maybe you've used something like pandas that's not super performance oriented, but it's just very nice to use. You can't really use that at serving time with latency constraints and many other problems that you just don't experience when you try to use your data in a common environment like a notebook. Which brings me to my second point, my third point, that real-time serving is very hard. Just about any team that I talk to that has engaged in creating a real-time serving pipeline has told me that this was not their most fun activity. And they would share some stories on how they've been setting up the infrastructure, how the team inevitably grew from 1 2 people to now dozens, and seemingly the problems just keep coming much faster than they can address them. Reconciling memory between multiple nodes, dealing with read-write congestions, with hotspotting, with load spikes, all of these are problems of real-time serving. And there is a reason why real-time data processing is typically the last topic of any data engineering curriculum. It's really hard. In fact, the amount of hurdles that teams have to jump through to make sure that their data can perform in real time with low latency is so high that many teams just don't go there. And they only operate on batch workloads. And I've seen many projects which can clearly be improved by replacing some kind of batch workload with a real-time endpoint, but the teams just don't go there. They feel like this is going to be way too complex of an architecture to maintain. And even though batch serving in a lot of times is an edge case of real-time, they still don't do it. The worst part about it is that the user experience is almost always better for a real-time serving because people just don't like to wait. And if your API can respond quickly, or the faster it can really respond, generally the better your system is. And if it responds fast, you still have a problem of serving the right data, which brings me to my last topic of feature engineering. Any of the data scientists who actually engaged in multiple new projects know this kind of beginning of a project where you just start from a blank state of a data set, trying to figure out which features to use, trying to transform your data, explore it. I think there's multiple studies that say something like 80% of data scientists' time is spent on data cleanup, data processing, and feature engineering. So maybe this whole affair should not be called machine learning, but feature engineering. And the process actually hasn't changed over the time. Despite seeing many innovations and with deep learning and transformer architectures, feature engineering is largely the same that it was like 10 years ago. You still have to just take the data, manipulate it, apply some transformation methods, review them, train the model with them, understand it, and likely be disappointed and do all over again until you find some features that actually work. And there's many algorithmic methods that help you do this much faster, like feature search algorithms, automated feature engineering algorithms, and they're still only in the nascency of their popularity. So this was just a subset of some problems. And I know it's the end of the day, and hopefully I got you a little bit worried about, well, am I doing data right with my machine learning stack, and do I need something to help me there? So the good news is that for the rest of my talk, I'm hopefully going to be calming down the anxiety because feature stores are the solution to the many of the problems that I've just described there. And they really are there to create, discover, manage, and serve ML features at scale. Feature stores are kind of like APIs to your data. You can think of it as an interface to the entirety of your data stack. They abstract the data engineering for your data scientists so that they can focus on creating the features and actually shipping those features into production. So I actually think that looking back at my diagram earlier today, feature store should be at the center because you don't usually interact with the data, you interact with the interface to that data or the tools that transform this data, and that's exactly what feature stores are. And they kind of had a bit of an ascent because just 5 years ago, I don't think that the product even existed. And now, in 2023, almost every company, not just AI leaders, not just the big names in the ML space, but just about every company either has a feature store or some concept of a feature store, or is very actively evaluating one. And that is why I'm so excited to tell you that Vertex AI has a new feature store. We have completely rebuilt it from scratch on top of BigQuery. This is the best data warehousing and data processing infrastructure in the world, and we're building right on top of it. We also completely re-engineered our serving stack. And we now have some of the lowest latencies for real-time serving of any feature store out there. And those of you who are experimenting, or maybe even not experimenting, but productionizing your generative AI apps, you no longer need a separate stack to manage data for Gen AI apps. You can do all of this inside of our feature store because we have built-in native methods for working with unstructured data and common tasks for generative AI. So, the new feature store doesn't just integrate with BigQuery. We actually have worked closely with the BigQuery team to make sure that you can access your BigQuery tables from the feature store without any overhead. So you don't have to copy the data and ingest it into feature stores like many products request. You can literally just call them using the standard BigQuery APIs. It just works. That also is brilliant for any kind of security setups you have with BigQuery already. You don't have to replicate them in feature store. They propagate. Now, our online serving latency now is at 2 milliseconds. This is really fast. This is as fast as you can probably get there for practical purposes, and it's definitely fast enough for you to no longer worry that you have to optimize your features for performance. Your read latencies, server side, it's going to be top notch. And of course, Google Cloud is one of the leaders in generative AI applications and research, so we had to make sure that feature store works well for your generative AI workloads. So we went ahead and we built in native support for embeddings in feature store. That means that you can store the embeddings in BigQuery. Feature store would create the index for them. It'll expose the API method to get similar items. You don't have to set up a separate vector database. You don't have to copy your data. You don't have to worry about a governance breach. You don't have to worry about sync conflicts. All of this is going to work within the same system, that system being feature store. And I wish I had more time in my session because the bottom of the slide is just as important as the top. There's many core feature store features that are available that I'm only going to talk about briefly. Things like versioning. Now change management is much easier. It's much more resemblant of your software engineering practice. Things like lineage. I mean, that deserves its own slide. Just all the different ways that you can trace how the feature evolved before it entered machine learning. Any of you who ever debugged a SKU or any kind of drift problem with machine learning knows that this can easily be a week-long procedure if you don't have any lineage tools. And all the known methods that we have for point-in-time lookups, web UIs, SDKs, and so forth. This is our architecture. You heard me mention that we're now built on BigQuery, and you may have been kind of questioning, so what does it mean? So I'm going to illustrate it for you. Actually, I'm going to start with a quick story, because the most common feedback we heard on our legacy feature store was that it has to work really well with BigQuery. So we actually got together with the BigQuery team, and we're like, how do we integrate? How do we make sure that this is the best integration out there? We started listing all the things that people expect out of the BigQuery system, out of the feature store system, like what do we overlap? And very quickly occurred to us that they're almost the same things that people ask for. So instead of integrating, we decided to build on top of BigQuery and basically make BigQuery the feature store. And it really helps that we're right next to the BigQuery team and we can actually do that. I know that many companies tried but couldn't get the same level of integration. And because it's built on BigQuery, it's right there in the middle of my diagram showing you that you'll use the native methods for data ingestion, for data reading. You can use all the same SQL. You can use all the same processing. All of it is powered by the core infrastructure that you're likely already using. As I like to say, instead of bringing your data into the feature store, we bring the feature store to your data. And those of you, hopefully very few, who don't know how good BigQuery is, I just want to give you a quick summary. BigQuery is one of the best data warehouses in terms of storing the data, retrieving the data, and ingesting the data. It integrates with just about any system out there, from Jira to Google Analytics to many, many different databases. It has a very active community if you want to know more about the integrations or debug them. And it has one of the most efficient storage systems in the world. And Feature Store does not require you to do any kind of post-processing when your data is in BigQuery. So as soon as it's available there, it's available for your ML workloads with no duplication. SQL is what drives BigQuery's interface. And boy, does it execute SQL well. Just about any transformation you're going to throw at it is likely going to complete in seconds and allow you infinite flexibility in how you define new features. And I don't have this in my slide, but actually, as of this conference, BigQuery no longer supports just SQL. We also have what we called BigFrames, which is a pandas-like Python interface for BigQuery. So you can now define your transformations not in just SQL. I know a lot of data scientists are not big fans, but you can actually define them in your familiar Python. You can have some tests against it. So everything as if you're writing code in your notebook. And the best part about it is that this is just the interface. The execution is still going to be on the BigQuery infrastructure, meaning that you'll get the best performance and the highest scalability out there among any data warehouses. And no story about data warehousing is complete without the talk on governance. And BigQuery has it all. Column level, row level, data set level, table level. You can define your governance and your permissions however way you want. And it's always a challenge to make sure that you're protecting the data, but also not making it a nightmare experience for somebody who's trying to consume this data. And BigQuery has all the controls for you to make sure the policy is flexible yet effective. And in Feature Store, we just use it as is. You don't have to replicate it, which is really, really nice because it really powers your governance story. The one area where BigQuery is not that great is real-time serving. It is really meant to be a batch processing warehouse. And that's where the Feature Store team came in. And as I said, we've actually rebuilt our serving stack. We used to be based on Cloud Bigtable, and it's still an option for all of you there. But we also have a new low-latency serving option, which delivers mind-boggling 2 millisecond serving side latency, which is really fast, probably faster than most feature stores out there. And for end-to-end latency, it's in about 5 milliseconds. And I know many people say that latency measurement, this kind of number throwing, is really complicated, really depends on the type of workload, on the size of data. So we ran quite a few benchmarks to arrive at our numbers, and we mostly compared with the workloads that we saw already. So we encourage you to do the same, and many of our benchmarks actually showed a lower than 2 millisecond latency, although I don't know many user experiences who would benefit lowering the latency even more. Our goal was to make sure that you have to not worry about latency anymore. You just build great user experiences, and you let Feature Store do the rest. And to help you with this, we made sure that it's trivial to set up an online Feature Store. All you have to do is write .create online store, set up your data sync policy, and you're done. Kaz is going to show it in just a minute. And not only it's easy to deploy the Feature Store, it's easy to maintain it too. As your workloads spike, we'll provision more servers. As they go down, we'll turn those servers down, make sure that you can accommodate any workload you want. 5,000 QPS, 10,000 QPS, 50,000 QPS, no problem at all. We'll make sure that we scale our infrastructure accordingly so you don't have to worry about it. And for those dealing with generative AI, I'm sure you've heard that the embeddings is the new most popular data type, at least for now. And you have to know how to work with this. The key operation on embeddings is similarity search, getting the similar items back. There's an entire industry now in vector databases trying to power this use case. There's all the different problems that you can run into as you try to introduce a new API into your stack, a new storage system into your stack, which is why we decided to build this inside of the Feature Store, inside of the same online serving endpoint you already use for the rest of your data. That way, there is no governance breach. There is no new API you have to learn, maintain, run security checks on. It's all built in one system. And our goal is to make sure that Feature Store works for all of your data. Structured, unstructured, predictive, or generative, all of this can be powered by Feature Store. We know that many machine learning use cases are train offline, serve online. So the methods for similarity retrieval are actually going to be available in BigQuery as well. So you can play with your system as you're training your model, and you can run those methods offline in distributed fashion. And then with just a few commands, you'll deploy it online, and it's going to be available there for all of your real-time retrieval. We take care of building the index. We take care of maintaining the instances. And there is a reason why there's high performance in the title of today's session, because we can support just about any embedding size. 1 gigabyte, 10, even 100 gigabyte embeddings indexes are totally fine. You'll still have milliseconds latency responses. We're powered by one of the algorithms that Google has used for many years, even in some production services like Google Search and YouTube, and we scale really well across all aspects of online serving. Now, there is much more to the feature store that I can cover today. Our data ops story is not going to be complete with just one slide. I hope that I'll have more follow-ups. But we have lineage, where you can see, literally you can click through and see all the tables involved in creating the feature, all the SQL that runs in between them. That's really cool. As I mentioned, when you're doing debugging, lifesaver. If you're just trying to run some broad queries and try to understand like what are the most kind of choke points, like what are some tables that power most of my ML workloads, you can do that too. There is versioning now. If you've ever done change management and you've just overwritten the feature values, I'm sure that your feature consumers have been not very happy with that practice, even though you had the best intentions. But just like software, you don't want your library that you've been using to just update randomly on you. Data is part of your software in machine learning. So you have to make sure that there is a proper change management process, and that's usually done through versions. You just publish a new version, you ask everybody to upgrade. You don't force them to. Online serving continues to deliver new challenges for us. So there's many edge cases that we're addressing, one of them being hotspotting, where you retrieve the same value over and over again. We created some cache mechanisms to make sure that this is effective. Point-in-time lookups, this is a staple of any feature store these days. We've done some performance optimizations there. There's a web UI, there's a Python SDK. We got you there for all of your data ops with Vertex AI Feature Store. And to show you, here's Kaz doing a demo.
We will take a look at how to use Feature Store to retrieve feature values instantly, as Alex mentioned, and use them for similarity search for real-time shopping experience. Let's imagine there is a sportswear shop introducing a new AI kiosk for the shoppers. They can scan an item with the kiosk and find similar items instantly to explore various options. To implement the AI kiosk, you would need a system like this. The first thing you need to do is to have the BigQuery table storing item features such as ID, name, price, and so on. Then apply an ML model to extract embeddings from the item features. In this demo, we used text embeddings generated from the item names. Lastly, you create a new online store instance that imports the item embeddings from the BigQuery table. By specifying the sync setting, the updates to the table will be automatically copied to the online store periodically. Then you are ready to fetch features from the online store. When the shopper scans the item with the kiosk, you can use the item ID to retrieve the item embeddings in a few milliseconds. The embeddings will be used to find similar items shown to the shopper. From the feature retrieval, similarity search, and to show the result to the user, it would only take tens of milliseconds. This is the real-time AI user experience you can build with the new Feature Store. So you may be wondering, can you use any arbitrary BigQuery table or view as an online store? The answer is yes, as long as the table or view follows the conditions here. The table should have an ID column, and the other columns should have the supported data types. It is recommended to limit the load size up to 10 megabytes to optimize the performance. And also, the table should be stored in the same region or multi-region. Those are the conditions. Now you can deploy the feature values to the online store in 3 steps. Create online store instance, register the BigQuery table or view, and set up a sync between them. So let's get into the demo. Okay, but I have prepared the notebook, but it's too busy and too small, so that I actually copy and take a screenshot of the important part. So let's look at those screenshots of the notebook. So this is the Sportswear shop's BigQuery table that has the item ID, name, category, price, and so on. Then I used the ml.embed text function of BigQuery ML to extract the text embedding from the item name and save them as a new table. We will let Feature Store read this table as feature values. To start working with Feature Store, you need to load the Feature Store SDK with those imports and get the client. With the client, you can call the function to create an online store instance. For the first time, it can take up to 10 minutes, but after that, you can get the instance in a second. Now, with the online store instance, you need to register a BigQuery table as a feature view. Feature view is a collection of features you want to use on the online service. The last step is to set up the sync between BigQuery table and online store. Here you specify the feature view to start syncing and check the sync process. The sync time will depend on the amount of the data you are syncing. In this example, my table has about 30,000 rows, and the sync took about 3 minutes. Now the online store is ready for serving. Let's take a look at how you can use it in this service. In your online service, you can get the client for the online store and call fetch feature values function by pressing the ID. And that's it. You will receive the feature values in a few milliseconds. You can use them for further search and recommendation. The new Feature Store has a low latency service, as Alex mentioned, which is blazingly fast. To test the latencies, I did a simple performance test. I load a for loop and measured the time to fetch the values for 1,000 times. The result you are seeing is 2 milliseconds. So online store works just like a local variable in your Python code that holds all the feature values automatically copied from your BigQuery table. No need for issuing an SQL query and wait for seconds to retrieve each item from databases. There's one more thing. As Alex mentioned earlier, the Feature Store can also support the retrieve items with similar embeddings without the need to set up additional services. Here I pass the item ID to find other items that have similar embeddings. Notice that how I didn't have to import any other libraries, set up another service, or copy data. It's all done by the Feature Store itself. It returns a list of the similar items and scores that I can use for the ranking. That's really nice if I wanted to combine the retrieved features for the recommendations or search use cases. Lastly, I'd like to share one more case of the shop scenario. That is an LLM integration. Suppose you're adding an AI chatbot to the AI kiosk using the LLM like Vertex AI Palm API. Also, the shop has the BigQuery table to track each customer's shopping activities, such as the Google Analytics log on the website or on-site item search history. So the Feature Store can feed those activities in real time. Now, when the customer starts the chatting with the AI kiosk, you can augment the LLM prompt with the last item the customer checked and have the personalized chat experience. You can easily fetch the last item from the online store for each customer and build a prompt like this. In this case, the customer had an interest in the Cloudville women's excursion short. So we want the LLM to lead the conversations for closing the deal with the item. The prompt goes like this. You are a personal shopping assistant in a sportswear shop. This customer looked at the Cloudville women's excursion short last time. Start the conversation to close the deal with this item. An example of the conversation with this prompt would be like this. Let's listen to it.
Hello.
Hello, welcome to our store. Can I help you find anything in particular?
Nothing particular. What do you have?
We have a wide variety of sportswear, including the Cloudville women's excursion short. These shorts are great for hiking, camping, or any other outdoor activity. They're made with a lightweight, water-resistant fabric that will keep you cool and dry even on the hottest days. Would you like to take a closer look?
So please note that I haven't created any part of this chatbot answer. all generated by the Palm API with the prompt built with the Feature Store. This is a simple example, but there is an endless possibilities of what you can do here.
Hello.
Oh, sorry.
Hello, welcome to our store. Can I help you find anything in particular?
Nothing particular. What do you have?
So in summary, the Feature Store, it's so easy to retrieve any features or embedding values of the items or customers or any other business entities in the real time. This enhances the ability of your machine learning model for real-time prediction, similarity search, or recommendation. Also, it empowers GenAI and its user experience with the dynamically built prompts. So that was the demo. Back to Alex.
So I've talked to you about the challenges in making data in production for machine learning. I've described the feature store, made a few announcements. Kaz showed you the demo. We played the audio segment twice. What else can I do to convince you that feature stores are there and that you should be using them? Well, one of the coolest things about working in Vertex AI is that I get to work with some of the most advanced companies in AI, and I get to advise them and also learn from them on how to build products. And a few of those companies sometimes go on record and describe the experiences they had with us building those products. One of those companies is Wayfair. They're one of the largest retailers. They're one of the largest e-commerce stores for furniture in the world. And they say that Vertex AI Feature Store presents a major operational win for their team. They love the BigQuery operations, and they believe that Feature Store has simplified their MLOps story. Another company that you probably know is Shopify, the second largest retailer in North America, and is really well known in machine learning and data engineering space. And they said that the new Vertex AI Feature Store is a significant improvement in the design of the Feature Store. They loved our low latency serving. It helps them create the magical experiences that the company is well known for. And we work very closely with that team to learn about how to build feature stores, what it means to have a feature store in a large company. There's a lot of fun conversations we had about the contracts between the feature producers and feature consumers. But what's best about both of those quotes is that both of these companies are very well known in ML space. They have thousands of engineers, definitely hundreds, maybe not thousands of ML engineers. And both of them chose to not build a feature store, but buy a feature store, because this is the type of product that may be best built by a company like Google. So that about concludes my talk. I have one last thing to say. The feature store is going to be available in September for everybody in this room and everybody outside of this room. We're going to enter public preview by the end of next month, so you can start reaching out to your sales reps and getting on the list. I want to conclude by saying that Feature Store is the type of product that really, for a lot of teams, marks the before and after era in their ML maturity. When implemented right and adopted fully, it really elevates your entire ML organization. So I hope to see you as one of the Feature Store customers, and I can't wait to hear what you get to build with it. Thank you.